Hello, you're welcome to our class in mathematics. And here we shall be looking at the topic gradients and lines. So in this topic, we shall be making use of our graph booklet. So here we have a graph. This is the x-axis and here is the y-axis. The x-axis is the horizontal line, while the y-axis is the vertical line. And they both intersect at a point which is O. So here is a linear equation which is represented by this line. Now we want to find the slope, also known as gradient. So another name for slope is also what? Gradient. So we are looking for the gradient of this line. Now to find the gradient, all we need to do is to draw a line down here and another line such that they meet at a point. Now this line proceeds in this direction, meaning that if here represents y1 and over here it represents y2, that means there's an increase from y1 to y2. And then when we trace this down here, we have this as x1, and when we trace this down here, we have our x2, meaning that there's an increase from x1 to x2. This point here is x1 y1, and then over here we could call this place, this is the x2 and this is y, so we'll call this place x2 y2. Likewise this point, we'll call this point x2 and y1. Now not forgetting that when we are stating this point, our x comes first, so we want to determine this slope, and to determine the slope we would say that slope over here is equal to increase in y over increase in x. For this particular line, let us call this point A, and let's call this point B, and let's call this point C. So we will say increase in y, which is coming from here to this place. That's increase in y, that is from C to B. Okay, so let's call this place M, which is more like the midpoint. So we'll say that there's an increase from y1 to y2, which is equivalent to saying M to B. So put it as increase in y, which is MB, over increase in x, that is x is increasing from x1 to x2. So we'll call this from A to M. We'll call this AM. So here is how we represent it. Now when we have this kind of linear graph, so both of them are increasing at the same time. Hence, the slope or the gradient we are going to have is going to be positive, because as y increases, y also increases. But let's take a look at this next graph. All right, so here is another graph, and in this graph we noticed the movement from here down in this direction. We have to get the gradient or slope of this linear equation. Now we could draw a line like this. Take your point from anywhere, and then you trace it down here, and then you trace this down here. Now you are saying that it started from here and then went in this direction, meaning that here is our y1 and then here is our y2, and then it's moved from here. So for our x1, here is x1 and here is x2. So we would say that there's a decrease in y and there is an increase in x. Now we represent this from here. Let us determine the coordinates of our points. The coordinates here, when we trace this down, which is x1 and this is y1, so we have it as x1 and y1. And then when we trace this down, we have this as y1 x2, so we'll call this x2 y2. And for this point, the coordinate of this point is, we have x2 y2. Now we can call this particular coordinates, this x1, y1 coordinates, we can call it C. Let's call it C. And let's call this x2, y2 coordinates. This is x2, y1. Alright, so we'll call these coordinates N. And then we'll call these coordinates, which is x2, y2, we'll call it D. Alright, so with that, we can find the gradient. So from here, we'll say the gradient will be, so we'll take the y. We know there's a decrease. So we'll have it as decrease in y over the increase in x. Now for the y, it's moved from here to here, which is equivalent to n to d. So we'll have it as nd. Now when there's a decrease, we'll have it as negative. And then for the change in x, which is an increase, which moves from here to here, is equivalent to c to n. So we'll have it as cn. So the gradient here is going to be a negative gradient. That is, the slope will be negative. Alright, so let's look at the following question. Find the gradient of the lines joining A, open bracket, minus 1, comma 2, close the bracket, and point B, 3, comma, minus 2. B, point C, open bracket, 0, comma, minus 1, close bracket, and point D, open bracket, 4, comma, 1, close bracket. C, point E, open bracket, minus 4, comma, minus 4, close bracket, and F, open bracket, minus 1, comma, 5. Now, we shall take this as our x1 and this is our y1. And then we have this as x2 and this is our y2. Alright, so for us to solve this question, let's put up a graph like this. This is the x-axis and here is the y-axis. Now for this, we are told that A, that's point A, is minus 1, comma 2. Now where is minus 1 on, this is x-axis, this is y, x and y. So on the x-axis, minus 1. On the x-axis, here is the x-axis and here is our minus 1. And then we trace it to where 2 is. So here is 2 on the y-axis. And so we'll tick this place. And then B, so this is point A. Now point B, we have 3 on the x-axis. So here is 3 on the x-axis. And then minus 2 on the y-axis. So minus 2 is over here. And so we'll trace it. So we'll have this. So we'll join the two lines. So here is A and here is point B. Alright, so with this, we're going to have a negative because here there's a decrease in the y and there's an increase in the x. So here is our point A. Now I want us to derive a formula here. This is A and then B, we have 3, comma, minus 2. So we want to derive a formula which is a decrease in y first. So the gradient here is going to be y2 minus y1 over x2 minus x1. Alright, move from here down here. So our y2 happens to be minus 2. We have minus 2 minus our y1 happens to be 2 over x2, which is 3. So we have 3 minus this x1, which is minus 1. And so we'll have minus 2 minus 2, which gives us minus 4. And then 3 minus minus 1. Now minus times minus gives us plus. So we have minus 4 over 4. And that is the slope, which is m, is equal to minus 1. And so we are going to make use of this particular equation more. So let's take a look at this. We have to find the gradient of the line joining these 2 points. So straight we could solve this without drawing on the graph by saying that slope equals to y2 minus y1 over x2 minus x1. So we have this as x1 and this as y1, here x2 and y2. So our y2 is 1, so have 1 minus y1 is minus 1 over x2, which is 4, minus x1, which is 0. So 1 minus minus 1 is, that's 1 plus 1, then 4 minus 0, which is 4. So we have 2 over 4, and so our slope is equal to 1 over 2. The next question. Alright, so this next one we have point E which has coordinate of -4, -4, and point F, which has coordinate of -1 and 5. And so we use the formula which we have slope equal to y2 minus y1 over x2 minus x1. Here, so here is x1, y1, x2, y2. So y2 is 5 and y1 is -4 over x2 is -1 minus, we have -4. Alright, so 5 minus -4. So minus times minus gives us plus. So we have 5 plus 4 over -1. Minus times minus, that's plus 4. 5 plus 4 gives 9 over -1 plus 4. And that gives us with 3. 9 divided by 3, that gives us 3. So slope or gradient equals to 3. Alright, so from this next question, it says draw the graph of the line represented by the equation 4x plus 2y equal to 5. And B says find the gradient by taking measurements. So here is the equation 4x plus 2y equal to 5. So we are here to draw the graph of line representing this equation. Alright, so the first thing we are going to do to draw a graph of a question like this is to first develop a table where we'll have x and y variables. We want to plot a graph passing through the origin. So we would have, when x is 0, what will be the value of y? Likewise, 1, 2, 3. You can have 4 numbers like this, and then you look for the value of y when x is any of these. Alright, so for if x is 0, what will be the value of y? So we'll have it as 4 into bracket 0 plus 2y equal to 5. 4 times 0 leaves us with 0, then 2y equal to 5. Hence we'll have 2y equal to 5. Divide both sides by 2. So we are left with what? 2.5. So when x is 0, y is what? 2.5. Alright, next, when x is 1, what will be the value of y? So we'll have 4 into bracket 1 plus 2y equal to 5. So we'll have 4 times 1 is 4, 2y equal to 5. 2y equal to 5 minus 4, and that leaves us with 1. So y equal to half, and so we'll have half over here. Next, what will be the value of y when x is 2? So we have 4 into bracket 2 plus 2y equal to 5. 4 times 2 gives 8 plus 2y equals to 5. So 2y equals 5 minus 8, and that's minus 3. That's 2y. So y equal to minus 3 over 2. And so we are having minus 1 whole number 1 over 2. And then what will be the value of y when x is 3? So we'll have 4 into bracket 3 plus 2y equal 5. 4 times 3 gives 12 plus 2y equal 5. So collect like terms, so we have 2y equal to 5 minus 12, and that gives us minus 7. So y equal to minus 7 over 2, and that leaves us with minus 3.5. So we have minus 3 number 1 over 2. So with this now, we'll take this as our coordinates, as our points. We'll take this as our different points. So when x is 0 and y is 2.5, we put a point there. When x is 1, y is half, we put a point there, and then we'll join the point to arrive at a linear equation or a linear graph. Alright, so here is our graph, and in this graph, when x is 0, y is 2.5. So this is our x-axis, and on this x-axis we have our 0 here, which is common with the y, and then y is 2.5. So we'll come over here, and between 2 and 3, that's where our 2.5 is. So we'll mark it over there like that. And then when x is 1, y is half. So here is our x, which is 1 here, then y is half. So half will be somewhere around here. So we'll trace it here and trace it over here, and then we'll have our half over here. And then when x is 2, y is minus half. So here is our x, which is 2. Then we have minus 1.5. So this is our y-axis, and this is -1. -1.5 will be middle here, and so we'll trace it down here, and then we'll have it over here. So here is our 1.5 for -1.5 for y-axis and 2 for x-axis. And lastly, when x is 3, y is -3.5. So we have x to be 3 here, and then we have -3.5. And so we have our 3.5 somewhere around here. Now if we take a close look at the difference between the y at y, 2.5 and half, the difference there is 2. So it's just like subtracting 2 from 2.5 to get this. Likewise, subtract 2.5, you get -1.5. Subtract 2 from -1.5 to get -2.5. Alright, so that's that, and then we'll draw our line. So here is our linear graph, or the linear equation. So simple, isn't it? Now we are asked to find the gradient of this line. So let's call this line AB. We will locate 2 points from which we are going to have our slope. Now because we know that this place is 2.5 and this is 0, we could trace this down to another known point, and over here I would say we should use -1.5 and 2. So we can trace this up. So we'll take this. Here is our slope. We want to determine the slope. Let's call this our point A actually. And what are the coordinates of point A? Over here, the x on the x-axis it is 0, and on the y-axis is 2.5. And then on this point, that is, we'll call this point point B. Now for this point B, we'll call this is the x-axis, which is 2, -1/2. So these are the coordinates of point B. Now for us to get our gradients, we would say change in y divided by change in x. So we'll have it as y2 minus y1 over x2 minus x1. This graph moves from up downwards in this direction. So this 0 is our x1, and here is y1, and here is x2, and here is y2. And so we would say that y2 minus y1, which is -1.5 minus y1. Our y1 over here is 2.5, because this is 2.5 over here. So we'll say -2.5 over our x2, which is 2. So we'll have it as 2 minus our x1, which is 0. So we would have -1.5 minus 2.5. So minus and minus. So it's more like adding it together. So minus is bracket 1.5 plus 2.5 over 2. And that gives us 2 plus 1, 3. That's 4. So we have -4 over 2. 2 into 4. And that's 2. So the gradient of this equation is -2. And as you can see, the gradient is negative. Alright, so in this next question, we're to draw the graph and find the gradient of the equation 7x plus 4y equal to 8. Alright, so for us to do that, we'll draw our table and we'll fix in values for x, such that when x is 0, what will be the corresponding value of y? When x is 1, what will be the corresponding value of 1? And so on. We'll go on by having our equation, that's 7, then we'll put 0 here, plus 4y equal to 8. What will be the value of y? 7 times 0 leaves us with 0, plus 4y equal to 8. So y equal to 8 divided by 4, and that is 2. So we'll have 2 here. Then when x is 1, we'll have 1 here, plus 4y equal to 8. What will be the value of y? 7 times 1 gives 7, plus 4y equal to 8. Here we'll have 4y equal to 8 minus 7. And so we would have 4y equal to 1. So y equal to 1 over 4. So we have this as 1 over 4. Then when x is 2, so we'll have 7 into bracket 2 plus 4y equal to 8. And so 2 times 7 is 14 plus 4y equal to 8. So we have 4y equal to 8 minus 14. And that leaves us with minus 6. So y equal to minus 6 over 4. So we have minus one odd number 1 over 2. With this, we have minus one odd number 1 over 2. Now, basically, having just 2 points here is sufficient to draw a line graph. But having a third line, we'll prove it further, and having a fourth point would even prove it much more. The third number, which is when x is 3, the value of y here will be 7x plus 4y equal to 8. So 7 into brackets 3 plus 4y equal to 8. So we have 21 plus 4y equal to 8. So we have 4y equal to 8 minus 21, and that leaves us with, that's minus 13. That's minus 13 over 4, and that leaves us with minus 3 number 1 over 4. And so we are going to plot this on the graph. So let's go ahead with it. When x is 0, so these are x-axis with 0 at the middle here, y is 2, so we'll trace it down to 2. Here is our 2. Then when x is 1, y is 1 over 4. So here is 1 for x-axis, y is 1 over 4, somewhere around here. And then when x is 2, y is minus 1.5. So when x, here is our x which is 2, then we have minus 1 odd number 1 over 2. So this is 1 odd number 1.5. So we'll trace it down here, and we'll have it somewhere here. And then when we have our x to be 3, y is minus 3 odd number 1 over 4. So we'll trace it down to this side, so somewhere around here. And then we'll join our points. We've joined the points, and this is the linear graph of 7x plus 4y equal to 8. So next we have to find the gradient. Now to find the gradient, we can make use of our known points, and then we'll draw a graph around it. Alright, so we'll have, let's call this point A, and at point A the coordinates are 0, 2, and then at point B, so our coordinates are 2, then 1.5. So we have minus 1 over 1 over 2. So we'll have it that our slope equal to the change in x. So here is x1, y1, and this is x2, y2. So we have y2 minus y1 over x2 minus x1. Here, the y2, that is minus 1 odd number 1 over 2. Then y1, which is 2, here. Then x2. x2 over here is 2. And x1 over here is 0. So minus 1.5 minus 2 is more like having minus 1 over 1 over 2 plus 2 over 2. So 1.5 plus 3, that leaves us with minus 3 over 1 over 2 over 2. We can convert this. 3 times 2 is 6 plus 1, that's 7 over 2 divided by 2. Don't forget we have a minus over here. So we have 7 over 2 times 1 over 2. When this division is changed to multiplication, we will have the fraction. We have a fraction here. And so we are left with minus 7 over 4. So we're looking at equation of a straight line. Now the equation of a straight line is giving us y equal to mx plus c, where y is the variable, m is the slope, x is also a variable, and c is the intercept of the line on the y-axis. So this is the intercept on y-axis. It's just like 0, c, that is where the line cuts the y-axis. You can determine the equation of a straight line. Now let us have point A. Now we want to determine the equation of a line passing through a point from a general point. So we'll call this the general point. and we call it xy. This is the general point, and this is point A. Now this is the point that we want to determine the equation for. We would say that to determine this equation, we will first find the gradient. So we will determine the gradient, and like we've always known that the gradient, which is the same thing as the slope, is equal to the change in the y-axis over the change in the x-axis. So whether it is that now, for instance, this moves from here upwards in this direction, and that means as y increases, so this is our y-axis, and we have this as our x-axis. So as y increase, x also increase here. So let's take this question. Determine the equation of a straight line whose gradient is minus 1 over 3 and that passes through the points minus 3, 2. Alright, so we have our gradient to be minus 1 over 3, and we have our points to be, so we have here as minus 3, 2, here is x1, and here is y1. Here we have to determine the equation of a straight line, that passes through this point and with this slope. We could take the equation which is y minus y1 equal to m into bracket x minus x1. We are saying that in this case now, it passes through this point and also a general point, in which this y and this x indicates the general points. Okay, so here we have our y, which is one of the general points, and then minus y1, which is 2, equal to slope we're given to be minus 1 over 3 into brackets x, which is one of the general points, minus x1, which is minus 3. And so we'll solve this. 1 minus 2, then minus 1 over 3 into bracket x, minus times minus gives us plus 3. And so we'll have 1 over 3 times x, we have minus x over 3, and then 1 over 3 times 3. So 1 over 3 times 3 leaves us with 1. So we'll have it as minus times plus here, which is minus 1. So we are left with 1 over here. And so we'll have y minus 2. The next is that we could collect the like term, that is, so we bring this minus 1 over here. So we have y equal to minus x over 3 minus 1 plus 2. So we have y is equal to minus x over 3 minus 1 plus 2. That leaves us with plus 1 all over 1. We look for the LCM. So LCM of 3 and 1, that's 3. 3 into 3, 1. 1 times minus x is minus x plus 1 in 3, 3. 3 times 1 is 3. So we have, now we cross multiply. We bring this x 3 over here. So that's 3y equal to 3 minus x. So here is the equation. 3y equal to 3 minus x. Alright, so still on deriving the equation where we have 2 points. So we have our m equal to y2 minus y1 over x2 minus x1. And now don't forget that when we consider that of a line passing through one point and then with a gradient, that equation gives us y minus y1 equal to m into bracket x minus x1. So deriving the third one, so we have we will substitute this for m. So we have y minus y1 equal to y2 minus y1 over x2 minus x1 to bracket x minus x1. And so what we'll do next is that we'll divide both sides by y2 minus y1 so that we'll eliminate this from here. And so when we get to do that, we have y minus y1 divided by y2 minus y1 is equal to x minus x1 over x2 minus x1. So here is our third equation. This equation is used for solving questions that's 2 given points. Alright, so let's look at an example of such question. Find the equation of the straight line passing through the points 1, 4 and minus 2 comma 6. All right, so we have our points. We have our points which is 1 comma 4 and minus 2 comma 6. So we have minus 2 comma 6. So we'll apply this formula, which is y minus y1 over y2 minus y1 equal to x minus x1 over x2 minus x1. So we have our y, which is 1, which is a general point, minus y1. Here we have x1, y1, x2, y2. y1 here is 4 over y2 minus y1, which is 6 minus 4, equal to x minus x1. So we have x minus x1, which is 1, and then x2 minus x1. We have minus 2 minus 1. Y minus 4. 6 minus 4 leaves us with 2. Then x minus 1. Then minus 2 minus 1. That leaves us with minus 3. Next is that we'll cross multiply, that is multiply minus 3 with y minus 4, and then multiply 2 with x minus 1. Minus 3 multiply y minus 4, and then 2 multiplies x minus 1. So 2 into bracket x minus 1. So here we have minus 3y minus 3 times minus 4. We have plus 12 equal to 2x. 2 times minus 1, that is minus 2. So we collect the like terms, that is the one that does not have any variable attached to it. So we have minus 3y equal to 2x minus 2 minus 12. So we have minus 3y equal to 2x minus 14. So what we could do is bring this minus 14 so that we eliminate all the minus that are here. So bring this minus 14 here. We have 14 is equal to 2x plus 3y. So here is the equation of these points, which is on a straight line. All right, so we want to look at gradients of a curve. First, what produces a curve? A curve is produced where we have a quadratic equation. So a quadratic equation has one of the variables having the highest power of 2. And so we could plot a quadratic equation on the graph, and that would give us a curve. Now, after plotting the curve, we can find the gradient. And the gradient of the curve at any point is defined as the gradient of the tangent to the curve at that point. Alright, so let's look at an example. Draw the graph of y equal to 1 over 4 x squared for values of x from minus 2 to 3. Find the gradient of the curve where x has the value of 3. That's a to be 3 and b minus 2. Okay, so we have our equation as y equal to 1 over 4 x squared. So you can have as a simple quadratic equation as this. So this applies to solving other questions where you have a quadratic function such as this. We have to make a table which runs from minus 2 to 3. So make our table and would put minus 2 into this x. And so let's see what it will give us. So y equal to 1 over 4. Then we have minus 2 squared. So we have 1 over 4 into bracket minus 2 times minus 2. That is 4. So 4 cancels 4. We are left with 1. So that's how we'll do for all the values of x. Then to determine the relative values of y. Okay, let's do this next one. We have y equal to 1 over 4 into bracket minus 1 squared. So we left with 1 over 4 times 1, because 1 squared minus 1 squared is still 1. So we are left with 1 over 4. For 0, we have y equal to 1 over 4 into bracket 0 squared. So 0 times this leaves us with 0. And so we can proceed and we have 1 over 4 over here. We have 1 here. And we have 2 number 1 over 4 over here. And then we'll plot our graph. We want to plot the graph of this table. So we have when x is minus 2, y is 1. We'll locate our minus 2 here. Now this is best done on a graph booklet. So have when x is minus 2, y is 1. So here is 1. So we'll place a point over here. Then when x is minus 1, y is 1 over 4. So when x, here is x to be minus 1, y is 1 over 4. So 1 over 4 is somewhere around here. Then when x is 0, y is 0. That means the curve passes through the origin. And then when x is 1, y is 1 over 4. So when x is 1, y is 1 over 4. So that will be somewhere around here. And then when x is 2, y is 1. So when x is 2, y is 1. So we have 1 over here. Okay. Then when x is 3, y is 2 whole number 1 over 4. So this is 3 for x axis. Then we have 2 over here. Then we'll move our hand up a little bit. So we'll have it somewhere around here. Okay, so we'll get a French curve that would enable us to curve this properly. Alright, so passing through this point. Now the next question now says that find the gradient of points where x has the value of 3. So where does x have a value of 3? Here it is. So where we have to find the gradient, so we'll trace it to where we have a 3, and then we'll draw a tangent at this point. Now after getting the tangent, then we can make a slope. When we use a proper graph book, we can have it as gradient. So a gradient at x equal to 3, we'll have something like 2.25 over, that is the change in the y, over the change in the x. You can have it as 1.5. So we'll have a gradient of 1 whole number 1 over 2. Okay, so the b aspect, we are told to find gradient at where x is minus 2. So here as well, we'll trace this up, and then we'll draw a line. All right, so after drawing the line, we'll find the gradient as well, just as we've been looking for the gradient. So we'll trace it down to the x-axis, and also to the y-axis, and then we'll now determine as gradient at x equal to minus 2. So it will give us something like minus 1 over 1. That's the difference in the change in the y-axis over change in the x-axis. So we'll have it as minus 1. So here are the solutions to the question.